Hello everyone, today in this video we'll be discussing the first module of machine learning BCS 602 6th semester subject, and in this video we'll be having the discussion of the most important topics. The topics, if you learn, you can easily score more than 80% marks, so watch this video till the end, don't miss any of these topics. These are very important ones, and I'll be telling you how to remember the important concepts. Okay, so if you have any questions or doubts, you can message me on Instagram _AFUU. So without wasting more time, let's get started. These are the topics. Don't worry, these are looking more, but you just need to know few points from each of these such that you can get more marks. Okay, so the first topic is the need for machine learning. Okay, so what is the need for machine learning? Why do we want machine learning? Okay, so what is machine learning? You are pretty aware of what is machine learning, but we'll be discussing the example and its definition at the later section. But now there are three reasons why there is a need for machine learning. Okay, the first thing is huge volume of available data is there to manage. Okay, what happens if we have huge data? If we have huge data, means we can derive useful insights from more data. See, less data will give us less information, right? If you have more data, we can get better information and more accurate information. That's why machine learning can be used in this part, such that machine learning can be trained on large data so that it will be more accurate. Okay, the accuracy will be increased. Second is cost of storage has reduced. We can store large data with very less costs. Okay, because previously 1 KB SD cards and all used to come, and that same cost now, how much we will be getting? 1 TB SD cards will be getting, right? So the cost has reduced for the storage. Availability of complex algorithms we have, so complex algorithms work very well with the machine learning. So these are the three reasons: volume of data is there, huge volume of data, and cost is reduced, and availability of complex algorithms is there. Okay, in the exam they can ask you the question why machine learning is used. You have to describe these three with example. Okay, and below shown is the knowledge pyramid. Okay, what do you mean by knowledge pyramid? How the data gets transferred to wisdom. Okay, so data which is mostly available as raw facts and symbols. Okay, the information is present here, but it is not understandable. Okay, it's just the data. Okay, and when it is processed, we'll be getting the information which is useful to us, and from that comes the knowledge which is in the condensed information, and this, when it is applied to some field, it will become the applied knowledge, and when the applied knowledge is taken to the next level, it will become wisdom, which means taking decisions appropriately. Okay, next topic is ML explained. ML is the field of study that gives computers the ability to learn without explicitly being programmed. Okay, computers can do some tasks and learn how the task is to be done without telling them how it is to be done. That will happen? That will happen by algorithms which will keep on learning on the data and its feedback. Okay, it is a loop kind of thing. Okay, that thing is called as machine learning, and below the difference shows the difference between humans and machine learning. Humans learn by experience. Okay, whatever has happened in our life, based on that experience we'll be taking the future decisions, right? Machine learning, what it will do, it will take the data, it will study the data, it will try to understand what are the patterns present and how it can be applied to the given problem, and it will be learning that and giving us an output model. What is a model? It is a formula, procedure, or representation that generates data decisions. Okay, and ML is related to other fields also. Okay, three fields it is related. How many fields it is related? Three fields: AI, data science, and statistics. AI is a huge part. Okay, AI, inside AI we get the machine learning, and inside machine learning we get the deep learning. Okay, AI is a general thing, like you'll be having water. Okay, now water can be of sweet water or salt water. In salt water also it can be hard water or soft water, like that. Okay, so salt water and water, like that. AI is the main thing, which means artificial intelligence. Okay, and inside that too, how is artificial intelligence trained? Based on machine learning. And how is machine learning actually working? Based on deep learning. Okay, so it is a part of the AI. ML is a part of AI. Big data is a part of data science that has three characteristics. See, we have to deal with big data now. What is big data? Big data means large data, the data which has a large volume. Okay, means data is more. Variety means many different types of data is there. Velocity means the data is very fastly increasing. Okay, the data is very fastly increasing, more data is coming, more data is going, like that. Okay, so these three characteristics are there, that is called as big data. Okay, and data mining means mining the data, means extracting the information and hidden patterns from the data, that is called as data mining. If we analyze the data, it is called as data analytics. Okay, and we will recognize the pattern, that is called as pattern recognition. So basically data science, inside data science we have machine learning. Machine learning has four things: data mining, data analytics, big data, and pattern recognition. Okay, And statistics is used in machine learning to find out patterns. In statistics we can have mathematical formulas and stuff, so that we'll be easily able to find out patterns used in the machine learning. Okay, and machine learning itself is divided into four parts. Okay, how many parts machine learning is divided into? Four parts. First is supervised learning, which is divided into classification and regression. Okay, we'll be discussing each one by one. First, let's discuss what is supervised learning. Okay, before that, let's have a look at the two types of data: labeled and unlabeled data. So this is the labeled data. Okay, labeled data means, what is this? This is a dog. And what is this? This is a cat. So dog and cat is written, that is called as labeled data. Unlabeled data will just be having these images. Okay, there will be no specific labels present to differentiate between them. So these are the two types of data. And supervised learning means there will be a learning in which it is supervised by a supervisor. So this is a supervisor, this is a computer. Computer will be doing something, supervisor will be seeing if the computer is doing right or not. If it's not doing right, it will stop and make it right what is to be done, and again it will be keep observing. That is called as supervised data. So two types are there: discrete and continuous. For discrete we'll be using the classification, okay, and continuous will be using regression. So what is classification? Classification means this data is present here, it is labeled data. Now based on the labeled data, AI will learn how to classify it. Okay, so if a new image is given, it will classify if it is a cat or a dog. Okay, that is called as classification. Few algorithms are there like decision tree, random forest, SVM, support vector machine, naive bayes, and artificial neural networks. Okay, like CNN. This is called as classification data. We have a label data, we are classifying it if it is of part A or part B. Okay, like output 1 or output 2. And regression means house price prediction, like something kind of like if the sales in the first and second week has been this much. First week it was this much, second week it was this much. Probably it will be third week, if we extend the graph, it will be this much. Fourth week probably it will be this much. So predicting the future results based on the past trend, that is called as regression. Okay, this kind of learning of the machine learning is called as regression. So supervised learning is of two types: regression and classification. Next comes the unsupervised learning. Here it automatically detects patterns and similarities and forms groups and clusters. Okay, if this is given, okay, it will form obviously two groups. Group 1 will be having of cats, group 2 will be having of dogs. Now if another group comes as bird, okay, another bird also comes, like a hen comes here. So in that case, this whole will be taken as one group animal, and this will be taken as bird group. Okay, so cluster will be from this one group, another cluster will be form of bird, that will be inside will be hen. Okay, so that is unsupervised learning. We are not specifically telling that there is a how many groups are there. Based on similarities it will be forming groups. Okay, so some examples are k-means and hierarchical algorithms. Next comes the dimensionality reduction. If it is 3D data, we are converting into 1D data, that is called as dimensionality reduction. Okay, that's all you have tried. High order data will convert into lower order data. And the difference between supervised and unsupervised learning is, in supervised learning will have supervisor component, here will not have it. Here it will be labeled and here it will be unlabeled data. Here the categories and labels are assigned. We are assigning cat and dog is present. Here it will not be assigned, just based on the characteristics and similarities and dissimilarities of the object, clusters and the groups will be formed. Okay, if there is a mix of both labeled and unlabeled data, we'll be using some semi-supervised learning. Okay, last one is reinforcement learning, where it interacts with the environment and learns what to do. Suppose there is a robot here. Okay, the robot has to reach the goal. Black, it will fall, it should avoid, and danger also, it will burn, it has to avoid. So it will try to go here, it will try to go here, and then it will from here it will try to go here, then it will learn you should not go there, then it will come back and go to here, then it will go to here, again it will go here, it will not learn not to go there, it will go here, not to learn, it will not to go there, then it will come back, it will go here, and then the goal will be reached. Based on the outputs and the actions, it is learning what to do and what not to do. That is called as reinforcement learning. Okay, here there will be two things: the reward and the punishment. Okay, reward and the punishment. The punishment has to be reduced and the reward has to be increased. So the reinforcement learning works on that principle. Okay, next topic is the challenges of machine learning. As we have seen that machine learning is very nice, but machine learning is not very nice as well. Okay, why it is not very nice? First reason is that it is deals with well posed problems. Ill posed problem it will not deal with. Okay, means confusing problems, but humans can deal with confusing problems more better than the machine learning. Okay, why? Because suppose that this is an example. Okay, here what you can see, two numbers x1 and x2. Okay, 1 1 2 1 3 1 4 1 and 5 1. Now the output should be, if 1 1 is given, the output should be 1. If 2 1 is given, output should be 2. 3 1 3, 4 1 4, and 5 1 5. But if machine learning is seeing this problem, what it will get confused is, if it is 1 into 1 is equal to 1, or 1 divided by 1 is 1, or 1 raised to 1 is 1. Like that it will have three possibilities, right? 2 into 1 is also 2, 2 divided by 1 is also 2, 2 raised to 1 is also 2, right? But humans will not think that much. they will see 1 2 3 4 5, something is increasing here, output will be 1 2 3 4 5, that's it, and 1 is here, we'll ignore 1, that's it. Okay, so the machine learning can't do that's it thing. Okay, that's it thing is specific to humans. Okay, that's the first challenge of machine learning. Next challenge of machine learning is that huge data it cannot process. Okay, if there is huge data, then it should be of quality data. If quality is not present, means some useless data is present inside, means it will corrupt the model. Okay, high computation power is required for running the ML algorithms. Complexity is also there, it has to handle the complexity, and bias and variance is there. Suppose that some lollipops are there. Okay, lollipops are there, and most of the lollipops are red in color. Okay, now if I ask it about the chicken, so what it will give you, it is the red chicken. Why? Because it was trained on the data where more red was there, so it will be biased to one specific output. Okay, that is an error of the model. So these are 5 challenges of the machine learning. First one is it will be dealing with the well posed problem, and it will not deal with the ill posed problem. Second is huge data is present, it will require huge computational power, the complex algorithms are there, and it will have bias and variance. Okay, moving on to the next topic, we have machine learning process. Okay, so it is a 6-step method. How machine learning learns. Okay, CRISP DM. What is CRISP DM? Cross industry standard process data mining. Okay, so understand the business is the first step. After you understand the business, try to gather the data which is relevant to that business, then process the data so that it becomes useful, model the data into a model, and evaluate the model if it is fine or not. If it is not fine, again model it, and then again check if it is fine or not. If it is fine, deploy it. And this is the 6-step process. Okay, the extra information is given here which you have to write in the exam. You can go through it. Okay, whatever I just told you, that's the same thing as it is written there. Okay, next is ML applications. Where all ML is used? First is in sentiment analysis. Sentiment means what? The emotions such as happy, sad, angry, which are captured by emoticons effectively. Okay, so if we are smiling, it should give us the result happy. If we are not smiling, it should give us the result sad. Okay, so based on the sentiment, if you are typing any text, we'll be able to understand if the person is sad or not. That analysis can be done by using the machine learning. Second is recommendation system. Most people recommend what is good, related book, which book is good, what is the best show we can watch on Netflix. All those things can be automated by using the machine learning. Third is the voice assistant like the Siri and the Alexa and all those things. Okay, like the voice assistant can be automated. And the last one is the technologies like Google Maps and Uber are all we will be using the maps so that the shortest path will be seen. The shortest path which is there, that will be identified by the machine learning. So 4 things are there: sentiment analysis, recommendation system, voice assistant, and technologies like the Google Maps and Uber. Okay, there the machine learning is used, and many other places it is used. You can go through the list here. Okay, you can use this list in the exam to write the examples. Okay, next part is the big data. Okay, introduction to big data. Let's understand some few things about big data. As I discussed, big data means very large data. Okay, so firstly volume should be more. Okay, then only it will be called as big data. Velocity should be more, the arrival speed of the data should be more. Okay, and variety of data should be there. There are different types of data, like the different forms of data, like that will be text data, graph data, audio, video data, and function of the data. What does the data do? Is it a human conversation? Is it a transaction record, or old archive data? Sources of data, where the data is we are getting from. Okay, there are some sources of data which I'll be discussing in the upcoming topics, where we are getting the data from. So that will form the variety of data, different kinds of data. Okay, veracity of data means that it will be having the trust, how much it is truthful data, believable data, confidence in the data, how much we can have. Okay, so that is the veracity of data. Authenticity, validity means it is valid or not. Okay, accurate or not. Okay, value means how much that data is present, what is the information we are getting, what is the valuable information which can be used. So that is carried by the value. Okay, so the 6 V's are there that will form the whole big data characteristics. Okay, that is a very important question from exam point of view. There are 3 types of big data. This is also very important: structured, unstructured, and semi-structured. Structured means what? By the name itself, we can understand that the data is structured. Okay, it's as simple as that. Stored in an organized manner. Okay, like for example, record data, data matrix, and the graph data. These data will be having the rows and columns, and everything will be organized. Okay, that is called as structured data. In unstructured data, it is not structured. Okay, like for example, audio and video. Audio will be like, for example, like this one, like this one. Again, it will be increasing, decreasing. And video, sometimes it will be very high, it will be very low. Here it will be good, here it will be bad. It is unstructured data. Okay, there is no some rows and columns where you can store the audio and video. Third is the XML and JSON, which is semi-structured data. Okay, some parts it has structure, some part it is unstructured. Okay, And where do we store the data? We can store the data as flat files like CSV. Okay, CSV means comma separated values. Like we'll be having CSV, like the words will be the comma separated. This is called as flat file. Okay. Next is the database. You can store in the database like SQL. And third is the XML, which is the extensible markup language. Using XML, we'll be storing the data. Okay, like in the XML format, we'll be storing the data. And next is the data stream. Data stream means continuous coming and going of data. There also data will be stored, because when it is coming, that place data is obviously stored. That's why only we are getting the data at the end. Next is the RSS, which is really simple syndication. Okay, it is also an instant sharing format across the services it is used. Okay, like the mails. JSON is also used to store the data in the interchange format, data interchange format. Okay. And data analytics means collecting, processing, and analyzing the data. Okay, three things are there. We are collecting the data, we are processing the data, means making the data more better, and analyzing the data means this data gives us what is the increasing trend of use of iPhones in the latest times, or it is a decreased use of Nokia in the latest times. Okay, which thing is there? Okay, that is the analysis. Okay, we are analyzing the data. Okay, so there are four types of data analytics: descriptive, diagnostic, predictive, and prescriptive. Okay, descriptive means what we are describing the data, what the data is. Okay, it is about describing the main features of data. Okay, that is called as descriptive analytics. Next is diagnostic. Diagnostic deals with why. Okay, suppose that a person has a disease, why the person has a disease, what is the symptoms. Okay, what has caused the disease. Diving deep and digging the data. Okay, the root cause, that is called as diagnostic. The third one is predictive. Predictive means that now we have a data that is telling us that customers are declining to buy a product. Okay, what is the future trend? If you don't do anything about it, it is most likely that customers will further reduce. Okay, prescriptive means what we can do to avoid this and make it in a upper scale. Okay, that means suggesting a solution. That kind of analysis is called as prescriptive analytics. So four things are there in the data analysis. First is descriptive, what the data is. Second is diagnostic, why that thing is happening. Third is predictive, if that keeps on happening, what will happen in the future. And fourth is prescriptive, suggest a solution to make that change. Okay, now what is big data analysis framework? To analyze something we need a framework. To big data analysis also we need a framework. Okay, for big data analysis we need a framework of four layers: data connection layer, data management layer, data analytics layer, presentation layer. Data connection layer, what it will do, it will bring data from different parts and it will store in one place. Okay, it will connect the data from the outer world to the inner world. Okay, manage of the data means how the performance is happening, which queries are running. Okay, all the queries of read and write operations are happening, how the operations are happening, which operation first, which second, which third. That management is data management layer. Data analytic layer will learn the data and understand the patterns and give us the outputs. And presentation layer will be having the dashboards where we'll be seeing the results. Okay, that is the four layer of the data analysis. So all these four layers work on two basic principles. The first one is the data collection and data processing, pre-processing. To collect the data is the first step. If you don't have data, we cannot process anything, right? And we need good data. What is a good data? Good data has the following properties. First is timeliness. The data which is used, that should be relevant and not obsolete data. Okay, relevancy. The data which is there, it should be relevant. Again, the same thing. Third is the knowledge about the data should be there. Whatever the data we are using, it should be understandable and interpretable. Okay, and where do we get the data from? First is the open or public data source. Okay, in digital libraries you can get scientific domains, or the healthcare systems you can get the data, or we can get the data from the social media also, and multimodal data also, like the text, video, audio, that kind of data we can get. Where you can get that from? Image archives and world wide web. In the internet we can get it. Okay, so these are the places we will be collecting the data. Okay, next comes the data pre-processing. Initially data is what? Data is dirty. Okay, repeat with me. Data is initially what? Data is dirty. We have to make it clean. What do you mean by dirty data? Dirty data means incomplete data. Outlier data means some extreme values are there which is not relevant, and data inconsistent values are there. Some is having like this value, like this value. This is useless data. Okay, inaccurate data, some false values are there in between, some missing values are there. The data is like this till here, then again it starts from here. This is a missing value. Okay, next is duplicate data. Like this graph is there, again like this graph, again like this graph for the same result. Okay, why there is three times graph? Okay, that is a useless data. So we have to clean the data. Okay, to clean the data, the following steps are followed. First is ignore the tuple. If there is a missing data, okay, in case there is a missing data, which data the whole row is, that whole row can be ignored. That is called as ignoring the data. And fill the data manually. What do you think that data can be there? If it is a missing data, you can fill it manually also. A global constant can be used wherever the empty space is there, everywhere I will fill. 4. Okay, the number 4. Like that I can choose any global constant and I can fill all the places there. Attribute will be filled by the attribute value, like average some value. Okay, like if the height is there, average height of the person will be like 5 or 6, like that. Okay, so it will be filled there. Next is the attribute mean for all samples. The mean value will be calculated and put in all the empty places. Last one is used most possible value. Whatever you think it's the most possible value, fill that value in there. Okay, and if now the missing data problem is solved. Sometimes there can be noise in the data. Noise means useless values. Okay, if you're listening to some podcast and behind someone is screaming, okay, what that scream is called, what that screaming is noise. You have to ignore the noise. How can we do that? So in order to ignore the noise, we'll be using two methods, the binning and smoothing. Okay, let's understand what it is. Suppose that this is a set here. Okay, in this set there is totally 9 elements. So we'll be dividing into 3 parts in bins of size 3. So bin 1 will have 12, 14, 19. Bin 2 will have 22, 24, 26, and bin 3 will have 28, 31, and 32. Now first step is using binning method. In binning method, what you'll do, find out the average of it and put it in all the places. Find out the average, put it in all the places. Find out the average, put it in all the places. That is binning method. Next is smoothing method. Smoothing means what? 14 is closest to 12 or 19. It is close to 12. So in place of 14, put 12. Means we are making data more similar. Okay. 24 is close to 22 or 26. It is both close, but we will choose the lower number. So 22, 22, 26. 31 close to 28 or 32. 32 is close, so it will be making as 32 here. Okay. So we are making the data more even. Okay. That is called as smoothing. So two types of there to remove the noise in the data: binning and smoothing. Okay, and data integration means a method of integrating the data. Means many places it is there, for multiple places we are putting into a single place. That is called integration of the data. And transformation of the data, we are using some methods. That methods we'll discuss why we use that methods to make the data more better, so that performance on the algorithms will be better. Algorithms will use data. If data is better, obviously algorithm will perform better, we'll get better results. So we'll transform the data into better data. Okay, two methods are used for that: min max and z score normalization. What is min max? Min max, suppose that this data is present here. How do we calculate min max? Is take the number which you are taking min, and max value you will take here. The max value in this data is 94. So 88 minus 88 and 94 minus 88 into 1 minus 0 we will do. Okay, so what answer we will be getting, that answer will be taken into consideration. For each number we have to do 90, 92, 84 and 88. When we do that, we'll be getting a final answer here, and these answers are in the range from 0 to 1. Okay, so min max value got turned into 0 to 1. Okay, so this is the set formed for this following set. This set is mapped to the new range. Okay, in between 0 and 1. This is called as min max. Second is z score normalization. Whatever the number is there, take out the mid number first. After you have taken out the mid number, subtract it with all the elements: 10 minus 20, 20 minus 20, 30 minus 20, and divide by 10. Okay, I always divide by 10, we'll be getting a value here. Okay, that value is called as z score normalization. Next is data reduction, reducing the data and so that the storage is less but the result is same. That is called as data reduction. So few methods can be used: data aggregation, feature selection, dimensionality reduction. Okay, the next topic is descriptive statistics. What does descriptive statistics do is, it will do the summarization of the data set. Data set is present here, I want a summary this much only, so it will reduce the bigger data set into smaller data set. That is called as descriptive statistics. Okay, and there are two types of data. Okay, what is a data set? It is a collection of data objects. Okay, different types of data, if you collect it, is called as data set. And there are two types of data: categorical and numerical data. And further they are divided into two parts. Categorical data means they will be having some specific values. Okay, for example, categorical data can be nominal or ordinal. Nominal means that this data which you have here, that is a nominal data. Okay, nominal data means if you find out the average of patient ID, that will be a useless value. What is the average of patient ID? What can I get by that? Nothing I can get. But average of age I can get some useful information. So which is useful, which is not useful, that differentiation is done by the nominal data. Next is ordinal data. Ordinal data means we'll be having a range if the fever is low, high or medium. Okay, but we cannot have the patient ID as ordinal data. Why? Because this is a number. Okay, nominal data, numbers cannot be processed. Okay, this is having a range, low, high. What, does patient ID have a range? No, that is stupidity. Okay, so numeric or qualitative data can also it will be divided into two parts. Okay, first is interval data, second is ratio data. Interval data means between what? between 30 to 40 degree, like that. Okay, ratio data means what is the ratio. Okay, means if you convert centigrade Celsius into Fahrenheit, we'll be getting two values, and those two values if we divide, we'll be getting a ratio that is called as ratio data. How much change is how much change has happened from the Celsius to Fahrenheit, that is called as ratio data. So types of data, two types: categorical and numerical. Categorical, we have the nominal data which cannot be processed. Ordinal data can be processed because it has a range. Numerical data will be having interval data which will be like 30 to 40 degree, and ordinal data will be having ratio. Okay, like how much change has happened. If an elephant became from this much to this much, what is the ratio change? The ratio change is 3x. Okay, that is called as ordinal data. I told it in the reverse way, but ordinal data is applicable for this also. Okay, ratio data. Next is another way in which it can be classified is discrete or continuous data. Okay, continuous data can be like this. Okay, if I plot a graph where the this is the person and this is the wealth. Okay, and the person's wealth is increasing with the time. Okay, so that is a continuous data. And discrete data means employee number one, employee number two, employee number three till employee number 1,000. Okay, so this is having numbers here. Okay, one number, two number, three number, like that. Okay, so this is called as the discrete data, where a specific number is there. Continuous data will not have a number, it will be having a range. Okay, from this age to this age, that is a range. In between, if you pinpoint, it will be some decimal value, that is a range data. Okay, so this is second type of classification, discrete or continuous. Third type of classification is based on how many variables are there: univariate, bivariate, multivariate. In this module we'll discuss the univariate. In the next module, module 2, we'll have the bivariate and multivariate discussion. So what is univariate data? There is only one variable. Okay, and what is the task of univariate data? To find the pattern. Okay, example, there are many types in which we can visualize this. Okay, so why is visualization needed? To understand the graph. Very simple. If visualization is there, we can understand the graph. See, within 1 second I can tell the student ID, the marks is increasing based on student ID. But if we see this one and this one, will take 1 minute to identify if what is happening, right? So visualization gives us faster results. So univariate data means one variable is there. Here only one variable is there, the student marks. ID is irrelevant, ID is all obviously present, the marks is the variable. Okay, so here one variable is the student marks, so that is the uh, univariate data. And this is the bar chart which is used to represent. Next is pie chart, if you represent in the form of percentages. Okay, next is the histogram. Histogram, what it will be there, range will be there from 25 to 50. Mark group range, how many people were there? One person was there. If 50 to 75, how many people were there? Two people were there. 75 to 100, how many people were there? Two people were only there. Okay, so this gives us the range, how many people have scored which how many marks, range of marks. Okay, and dot plots, instead of the bar chart, we'll be using dots or patterns, that is called as dot plots. Okay, next, the central tendency, where we'll use three things to summarize the data. Okay, first is the mean. We'll be calculating the mean, which means average, right? Whatever the numbers are there, add up all of them and divide how many numbers are there. If five people are there, calculate the sum of the weights of five people and divide by 5, that will be getting the average weight. Okay, that is called as mean. Next is the median. Median means what? The things are present here. The numbers are present and the items are present. If you arrange in the increasing order, you'll be getting two mid values, that is called as median. And mode means how many times a particular thing has appeared, that is called as mode. Okay, frequency. Okay, and dispersion means that how many around the central tendency, how is the data present. Okay, means data is inclined more to the center or more to the starting and ending part. Okay, so for that, range is used and standard deviation is used. Okay, this formula will be used for the standard deviation. Another thing can be used is the quartile and interquartile range. Okay, interquartile and quartile range, what does this mean? This means that suppose this data is there. Okay, if you find out the quartile 0.25, means in this whole data, the 25%. Okay, what is the 25% this of this whole data? It is 16.5. Below 16.5, how many values are there? If we find 75, it is 29.5. Below 29.5, how many values are there? That number of values is called quartile. And if we subtract two quartiles, we will get interquartile range. Okay, and if we represent the minimum, Q1, it means the quartile 1, and the quartile whichever we want, quartile 3, median and maximum values in a single place, will be getting a 5-point summary box plot. Okay, this is a 5-point summary box plot. Okay, and we'll be also using the shape, which is skewness and kurtosis. Skewness means that how much data is biased to one position. Okay, means if the more data is present in the starting part, it is positive skewed. If the data is more to the ending part, it is negative skewed. Okay, data is not distributed equally. Ideally it should be zero, means the skewness should be zero. Okay, it should be ideally distributed, but sometimes more data will be present at the start or the end, that is called as skewness. Okay, second is kurtosis. Okay, kurtosis means what? We'll be using peaks of data. Means suppose data is there, it is increasing like this, then it is increasing like this, the peaks are there here, right? That is the kurtosis of the data. Okay, two other useful measures are there. Mean absolute deviation, we will be using this formula, and coefficient of variation, CV, is also used in this formula. Okay, the last topic is special univariate plots. Okay, to plot the univariate data, we'll be having two things. The first is stem leaf plot. Okay, stem leaf plot. Second is QQ plot. Okay, and the expectation is that it will be on a bell shaped data. Bell shaped curve means this is the starting part, this is the ending part. In the middle it should be the highest, in the ends it should be the lowest. That kind of representation we get, it is called as the ideal data. Okay, and the first kind of data where we will be representing is the stem leaf kind. Okay, stem leaf means suppose we have 45 marks in English, 4 will be taken as stem and leaf will be taken as 5. 66 will be taken here and zeros will be taken here, because 2 times 60 is there and zeros is there. 80 with 8, it will be 0 here. 85, 5 will be here. So this is one leaf, this is one, this is one leaf, and this is one leaf with the stems. Okay, two leaves are there for each stem, so most probably this will be the range. Okay, that kind of analysis is called as stem leaf analysis. Next is QQ plot. In QQ plot, we'll be plotting the points here and we'll be drawing an average, and how close it is to the average, that much it is ideal data. Okay, that kind of analysis is called QQ plot analysis. So this comes under the special univariate plots. Okay, that's all from this video, and if you like this video, hit the like button and subscribe to the channel for more videos like this. Don't miss any of these questions, these are the super important ones. And thank you so much for watching. I'll see you in the next one.